Well, good afternoon, everyone, and welcome to the Past Performance Virtual Chapter, our meeting for February. My name is Ryan Adams. I'm the president of the chapter, and I will be your moderator today. If you want to follow me on Twitter, you can. I'm at Ryan J. Adams on Twitter. Our chapter is also on Twitter as well, so if you want to follow us out there, we're at SQLPass_PVC. We also use a hashtag, so if you want to use the hash PassPVC for any questions, or you want to have any discussions during the presentation today, you can follow us out there on our hashtag. Of course, our website address, performance.sqlpass.org. We also have a discussion list, so we use Google Groups. It's just an open list. Anybody can join that, pervc@googlegroups.com. If you've got a performance-related question, feel free to join the group, throw your question out there. That's an open, free resource. You'll get people responding and ideas and suggestions and stuff, so if you've got something you're stuck at with work or just a general performance-related question you're kind of curious about, absolutely make use of that discussion list there, and that's what it's for. If you want to talk to anybody that's helping out with the chapter, any of the virtual chapter team, you can always shoot an email to performance@sqlpass.org. We'll be more than happy to help you out. So if you're looking for any technical assistance as we use GoToWebinar today, there is a raise hand button. You'll see the picture there on the far left. The raise hand button is the one at the bottom. The other interesting thing is you'll notice that there's a little red arrow up at the top. So as we start, the pane will actually slide over to the right and kind of hide itself. If you click the red arrow, it will expand back out, and that'll allow you to see the additional options, like the questions pane. If you have any questions during the presentation, you can use that, type your questions in there, and we will get those answered for you. If you find that it's a little hard to see the screen and you want to maximize it inside of the display window, you can click the zoom button, and you can adjust the zoom level if you so desire. Audio is only available through your computer speakers, so unfortunately there is not any type of dial-in number. It is all voice over IP through GoToWebinar. We do want to thank our sponsor, SolarWinds. SolarWinds has graciously offered to sponsor our chapter for the entire year again. We are very thankful to have them as a partner with our chapter, and we appreciate their support. And because of that, we'll be able to give away a $100 Amazon gift card to everybody that, not to everybody, but to a random person that has attended the webinar today. Someone will win a $100 gift card, and we'll email that person within the next day or two. So we definitely want to thank SolarWinds for doing that for us. We also want you to be aware of the Past Business Analytics Conference that's coming up. It'll be held in Santa Clara, California here in April. If you're looking to attend the Business Analytics Conference, if you look at the very bottom of the slide there, there's a code. Now you can find this code if you don't have time to write it down, that BAVCPE. If you don't have time to write that down, you can always go hit performance.sqlpass.org, and we've got it posted right there on the front page of our website on the right-hand side for you if you forget what that is. But that code will save you $150 off. PASS also sent out another incentive that you can use in addition to this, that if you put out this code, you not only save $150 when you register, but there's a referral program in there. And if you refer somebody and say, look, this person referred me to the Business Analytics Conference, then you'll be able to get a Fitbit. Not only you, but the person you referred. So if you're in need of a referral or something like that, let me know. We can find somebody to give you a referral name for that. But make sure you take advantage of those two offers. For today's presentation, we're very happy to have Tim Chapman here speaking for us today. He's going to be talking about performance problems and how to troubleshoot those like a Microsoft engineer. With that, Tim, I'm going to kind of let you introduce yourself a little bit more. I'm going to make you the presenter and hand it off to you.
Okay, thanks, Ryan. I'll go kind of in presenter mode here. Showing the screen. Okay, so while that's kicking in, welcome everyone. My name is Tim Chapman. I'm an engineer at Microsoft, and today I'm going to be talking about how we as Microsoft engineers go about troubleshooting some common performance problems. We'll talk about the tools that we use along with some of the methodologies, and we'll talk a lot about waits and queues. Everyone knows, or at least hopefully familiar with the idea of performance tuning with waits. Well, I'm going to take it a step further today and focus more on the queues aspect and how you can use perfmon to help troubleshoot some of these problems. A little bit about me, just briefly, I'm an engineer at Microsoft. I've been here for a little over 4 years. I've done some contributing to a couple of different books, and I'm a Microsoft Certified Master in SQL Server 2008. So, what we're going to talk about today, I'm going to talk briefly about the tools that we use as engineers and how you can take advantage of these tools to run your own performance diagnostics against your systems. Whether you're a consultant or you work as a DBA, you can use these tools. They're free to download, they're free to modify, and they do help take a big step forward in how you can automate performance capturing and diagnosis of performance issues on your system. Once we look at the tools, then I'm going to dig into an overview of troubleshooting, and we're going to look extensively at weights and queues with a focus on queues, just because not a lot of people out there focus on the queues aspect of weights and queues, and it can be tremendously useful in terms of troubleshooting problems. Any questions you have, try to save them to the end, or at least I will try to field as many as I can at the end, just because I do have quite a bit of content today and I want to make sure I get through as much as possible. First up, SQL Diag. SQL Diag is a tool that ships with SQL Server, and it's basically a vehicle for which you can use to gather information about your instances on your machine. So we'll gather perfmon information, we'll gather error logs, profiler traces, any sort of blocking information, any sort of custom scripts that you may want to run. We can collect it with SQL Diag. If you've ever worked with a Microsoft engineer and they have sent you a PSS Diag, the PSS Diag is just a wrapper for calling SQL Diag behind the scenes. So PSS Diag in and of itself doesn't provide a whole lot of functionality in terms of collecting the information itself. It specifies what to collect, but SQL Diag really does the bulk of the work behind the scenes. It ships with SQL Server again. It's in your installation directory in your tools bin folder. And you can double click it and it'll start collecting information, but the main thing to take away here is that there are XML files that are passed to SQL Diag whenever it is collecting information, whether you specify it or not, and you can modify those XML files to collect essentially whatever information you want to collect. Diag Manager, this is a tool that you can get from Codeplex, and it's essentially the same tool that we use as Microsoft engineers to allow the collection of information from Microsoft remote SQL Server installations. There are a couple things to take away here. Let me get my trusty pen out. There is the platform, which you'll need to choose. In most cases these days, you'll want to choose the 64-bit platform because that is what you're going to be running for your for most production level installations. That's not the default, at least on the publicly available version that I'm familiar with. 32 bits the default. You'll want to choose that first, because if you don't, any other choices you make out here, once you switch platforms, will go away. You can specify the machine name and the instance name. You don't necessarily need to. I usually take the same defaults for perfmon because I like to collect as much perfmon information as possible, and it doesn't introduce that much of an overhead on a SQL Server system. However, SQL Trace can. The more events that you capture through SQL Trace, the more overhead is going to be introduced on your SQL Server instances. So if you have to collect trace information, only collect the bare minimum that you need. I usually uncheck this. It is checked by default. Under Custom Diagnostics, you can specify any additional scripts that you want to collect. I'm not going to talk about how you do that today. I did a talk for the 24 Hours of Pass where I go over how you can collect all your own custom diagnostics so that you can run essentially your own custom health check on any system that you want. And I have a link in this talk to go back to the 24 Hours of Pass talk if you want to review that. Now notice up here, in the public version, as far as I know, we only have SQL Server 2008. You may be curious about SQL Server 2012 and 2014. You can use Diag Manager for those instances as well. It's just a small change that you have to make in the XML file. And in my 24 Hours of Pass talk, I show you where to make that change. In terms of capturing custom data, just briefly here I want to talk about this. There is a custom collectors. You go to details, and then you can enter your own custom scripts there. You have to have them saved to a specific directory, and I show that directory in my 24 hours of past time. Once you've collected that information, then you need to be able to do something with it, because what SQL Diag Manager is going to do is it's going to create a wrapper for PSS Diag. It's going to collect that information. It's going to post that information to an output directory, and all that information is going to be text files. Well, you can use SQL Nexus to go point to that output directory, and this is going to be a folder that is zipped up from a customer, or you're going to have it on one of your local SQL Server instances. You can copy that information to a local machine for your own analysis, load it up in SQL Nexus. SQL Nexus is configurable so that if you have your own custom data that you collected, it's able to read that data and load it in to SQL Server tables, and then you can run your own reports off of those SQL Server tables. To be able to use SQL Nexus, you're going to have to install the RML utilities, which you can download from the links that I have available here. And all these tools are free. And you have the source code. The source code is available on CodePlex if you did want to modify it for your own uses. Here is the link to the 24 hours of past talk that I did, where I go over how you can customize using PSS Diag and SQL Nexus. I show you how you can create or modify the configuration files for PSS Diag captures, and how you can import that data into SQL Nexus to create your own rules engine against SQL Server instances on your environment or customer environments to essentially create your own custom health check if you want to do that. And one thing to take mention of here is that, again, PSS Diag excuse me, does not just collect SQL Server information. You can run different scripts on the server itself. We collect perfmon, so a very valuable tool in terms of not just looking at the SQL instance, but looking at the overall server health as a whole. So on to troubleshooting techniques. There are many different techniques for troubleshooting, and it's an iterative process. So first, the first step along the way is defining the problem. Hopefully, you're actively going out and looking on servers to try to define these types of problems. But more times than not, someone has come to you with a problem for you to try to fix. And so you have to define exactly what the problem is. Next up is gathering data on this problem. This can be as easy as using PSS Diag and capturing the information, or running your own scripts on the instance to gather D&D information, looking at perfmon, and so on. But you need empirical evidence to try to pinpoint the problem, to make sure that not only is what the person described accurate in terms of it actually being a problem, but if you have data on it and you tune along the way, you want to make sure that your data changes excuse me, in regards to that problem, so that you know that you're making headway. So just anecdotally defining the problem and going to try to fix it is not the best way to troubleshoot and fix some of these problems. You want to have data, you want to define the problem, gather data, analyze the data to make sure that what the defined problem is actually the problem, make a change along the way, and then regather data and validate that the change has fixed the problem. If it doesn't, gather data again, analyze, rinse, and repeat. It's an iterative process. The more you do it, the better you're going to get at it, and usually you'll be able to fix it the first iteration around. That's not always going to be the case, and sometimes you have to go through several different cycles, gathering data, fixing it, just to make sure that the problem is solved. And sometimes the problems are pretty complex, and you have to fix different things along the way to fix the overall problem. So it's an iterative process for sure. On to weights and queues. So you've probably heard of the concept of a weight. And anytime in SQL Server whenever we're performing some sort of task and we need to access some sort of resource, we keep track of the resource that we're waiting on and how long we're waiting on that resource so that we are able to identify where our bottlenecks are. It's a pretty nice methodology for defining where on my SQL Server instance I'm spending most of my time. And it relates most oftenly, not always, but pretty frequently, to perfmon counters at the machine level. Not always, but in a lot of cases, I can pinpoint problems that I'm having in SQL, what I'm waiting on, with some sort of resource that I'm waiting on at the machine level. Okay, there's a correlation between the two, and that's why we refer to it as waits and queues. Most websites and talks out there focus on waits, but there's also a very powerful aspect to waits and queues using perfmon information to try to identify the problems. Okay, a lot of times I can go in and I can analyze perfmon information and figure out what a SQL Server problem is just by looking at resources being used on the server. Not all the time, but there's no golden ticket here, but a lot of times it does point me in the right direction. And hopefully I'm able to talk about some of those useful counters today and bestow some of that experience that I've had over the years. So how can it help you? Essentially, to help you avoid troubleshooting the wrong bottleneck. If someone comes to you and tells you that the server is slow, and that's all that they're experiencing, how do you go about troubleshooting that particular problem? Okay. If you have tools in place to be able to identify that type of information, if you've done a little bit of work ahead of time on all of your servers, then it could help you a long way in terms of fixing problems and, better yet, even finding problems before there are problems so that the users don't have to come to you and complain about them. Get the biggest payoff for your performance tuning efforts. It's really easy to write something that is going to go out, take some information from a few DMVs on the system, archive them over time, and then put a couple of T-SQL queries on those tables to identify where you're having pain points throughout the day. It's really easy to do that, and it will go a long way in terms of how you can proactively fix issues before they become big issues on your system. Find non-obvious performance-related bottlenecks. How often do you know that you're having problems with memory grants on your system? It's probably going to manifest itself as a slow query, or it may even look like it's blocking on the system. But if you are using waits and queues, you'll be able to identify pending memory grants, again, before they become big issues. And you're able to identify them much quicker based on the type of wait and some pretty useful perfmon counters to go. It's, again, one of the first steps I look at in terms of looking to see what the problem is on the system. Too many times over the years, someone has come to a DBA, or I've seen this where someone will come and say, hey, the system's slow, can you see what's going on? And the very first step is open up SQL Server Profiler, throw a lot of events in there, and try to figure out from there what the problem is. It's like reading the matrix if you haven't stopped the screen and it keeps scrolling on you. So using waits and queues is going to be a very good step in terms of identifying these problems as opposed to other tools. Now, DMVs is a great step, right, if you know what to look at. Error logs, different types of logs may be, depending on what the problem is. Execution plans are great if you know exactly what the offending query is. And a lot of times it's not a query. It's something in the background that's causing a query to be slow. So some examples. I mentioned this in passing already. An end-user customer comes to you and says, hey, something's slow on the system. Can you try to figure out what it is? Right? This, whenever a user comes to you and says something like this, you're going to hopefully go through a set of questions asking the user what their experience is, and depending upon what the user does, and what exactly their job function is on a day-to-day basis, they may be able to give you some information, or they may not. If it's just an end user that comes in and they use the system from 9 to 5 and they know that their application is slow, they're not going to be able to tell you a whole lot except for maybe when during the day the application is slow and for how long and what it is in the app that they're doing. Not a whole lot of information to go by, especially if you don't know the application. It's a vendor app, for example. You're looking for ways to speed up a database-driven application, and you want to identify the bottleneck. That may be related to the first example, but again, it's hard to sometimes know exactly where to start. Waits and queues can point you many times in the right direction. Benchmarking. Okay. Collecting DMD information and perfmon information is an incredibly powerful tool for benchmarking and trending, because in terms of benchmarking, if you have a benchmark or a baseline on your system and someone tells you that something is slow, I can take another snapshot or a capture on my system right now, compare the two, and I will be able to tell what is different as compared to my baseline. Right? I can use that same information for trending purposes. So if I know that 8 a.m. is my peak time in terms of batch requests per second, and I'm usually experiencing 50, or we'll say 10,000 batch requests per second, and for some reason on Tuesday, even though it's usually 10,000, it's jumped up to 40,000. Why is that happening? Has there been an application change? So I would have that information if I had a baseline, and using perfmon and or DMDs is a great way to capture this information. Taking a step back, I've mentioned perfmon a couple times. In SQL Server, we do expose SQL Server related counters to a DMD, and you can capture that. The trick there is that it's somewhat difficult to be able to, especially the counters where it's like transactions or batch requests per second, you have to be able to calculate that on the fly, which is not the most trivial thing in the world to do. So in my opinion, capturing perfmon and then importing into the database somehow, SQL Nexus is a good way to do that, or using RML utilities is a great way to do that. So many times, you're not just bound by one particular resource bottleneck. If you're lucky, you are, but often there's more than one. Okay? And when I say resources, I mean CPU, I mean memory, I mean disk, and sometimes I mean application code. Okay? It's not necessarily a resource bottleneck, it's not something you can buy, but when you think about it, if your application code is bad, you can throw a lot of resources at that application code and you still may not be able to overcome that bottleneck. Right? But at least you would know where your bottleneck is if you have a proper methodology to identify those problems and do something about it. Okay? So again, the approach. Identify resources that are my main bottleneck, and sometimes you won't have bottlenecks on your physical resources on your machine. You're just bound by app code, and that's common, actually. If you have offenders that are in your app code, find the statements that are using the most resources. And I'm going to talk about what statement, or how you can go about finding those statements in just a few minutes. Tune or optimize usage. That goes for app code. That also goes for resources as well. If I have an application out there that is submitting thousands and thousands and thousands of really small transactions, and I have WRITELOG waits because my underlying system can't keep up with the very small transactions that I am submitting, is there anything I can do in the application code to fix that? A lot of times the answer is no, but sometimes the answer is yes. Okay? And repeat the process. Repeat it until you have fixed the problem. Now, as a caveat to this, you don't want to take a system that is heavily used and keep repeating this process on it because there will be a point of diminishing return. In most cases, most systems, you could optimize the heck out of it till kingdom come, but there's going to be a point of diminishing return where you can keep working on it, but you're not going to make it that much faster. And you want to avoid those situations. And if you're properly using waits and queues, you'll be able to identify when that issue is, and then move on to some other system. And I've seen engineers out there that have a system that's actually not too slow, but because the business thinks it's slow or they want to put an onus on that system, they keep spending resources on it, even though it's about as fast as it's going to be given the current architecture. So something to keep in mind there. So taking a step back in terms of how SQL Server is going to go out and schedule tasks. First, whenever you connect to SQL Server, a session is created. We'll create a session, and there's DMDs you can go out and look to identify certain session level settings. Then, when SQL Server accepts a batch from that session, so say you're in Management Studio and you've written a query, or your application has connected to the instance and it's submitted the query to be executed, we're going to take that batch and we're going to assign it a task. Now that task is going to be bound to one or more worker threads. And a worker thread is, think of it as a CPU on the system. So a worker is going to be bound to a CPU, and one or more workers are going to be bound to tasks, and then we're going to execute whatever that task is on a scheduler. Okay, a scheduler is a logical CPU that SQL Server sees and recovers. So an application connects, submits a session, that session has a batch. We're going to execute that batch, whether that's one statement or 50 different statements. It really doesn't matter to us. We're going to assign tasks to that batch, and then we're going to distribute, if we need to, those tasks to different workers or to one single worker, and then that work is eventually going to get executed on the schedule. Now, the different states a session can be in. There's a couple of other ones other than these, but there's really three that you are going to be concerned with. There is the running state. In the running state, you can only have one task on a given scheduler at any one time. Now, this becomes a little more tricky because most CPUs or most servers out there have multiple schedulers, and with multiple schedulers you can have multiple tasks running at any given time, and that's perfectly fine. We're just going to imagine that we're on a symmetric multiprocessing machine right now, or sorry, a single scheduler machine right now. Okay, so a task eventually waits to get onto a scheduler, and then once it's able to perform its work, it's in a running state. So if you have 8 logical CPUs on a given server, you can have 8 at the most running at any given time. A task can be runnable, which means that that task has all the resources that it needs to run, but it does not have access to the CPU yet. Right? If a session is in a runnable state, that's a pure CPU wait, okay, because it's just waiting to get on the CPU. Now, taking another quick step back, under the covers, SQL Server has its own operating system. And this operating system is responsible for all the scheduling that SQL Server does. And this operating system has hooks into the Windows operating system so that these tasks and these CPUs can be scheduled to run. SQL Server's preemptive, it's non-preemptive because the SQL Server operating system, all of the logic for taking work off and onto schedulers is in the worker threads themselves. The Windows operating system is a general purpose operating system, and its goal is to make sure that no one application monopolizes these CPUs. So it's preemptive, so the operating system itself will take threads off the CPU whenever it sees fit. The SQL Server is responsible for doing this itself. So there's a quantum that each worker thread has, and I think it's about 4 milliseconds. So if a thread is on a scheduler and it's in a running state for a certain amount of time, it will take itself off so that it does not monopolize that scheduler to allow other threads to do work that they need to do. All right. So if something's running, it's running, and that's great. If something's runnable, that means it has its resources that it needs, and it's just waiting to get onto the CPU. If something is in a waiting state, that means it's waiting on some resource that's not signal time. It's not waiting on the to get onto the CPU. It's waiting for some other resource, like disk I/O, like a memory grant, like a lock. It's waiting on some sort of resource. And along the way, we are keeping track of what that particular thread is waiting on. Okay, so if it's in a runnable state, we're keeping track of something called signal wait time, which means that task is waiting for a signal to get onto the CPU. If we're waiting on some other resource, we're keeping track of what resource we're waiting on and how long we're waiting on it. And that represents the waits portion of the waits and queues methodology. If I want to see what's running right now, I look in sys.vm exec requests, and I look for the given state of the thread. I can also look in exec request for what's runnable, so it'll have that session will have a state. It'll state as runnable. Usually these are pretty quick, so if you run exec request and then you run it again, you hopefully won't see the same session in a runnable state without it having at least access to CPU. And then if something is waiting, you can look in exec request or sys.vm os waiting tasks. The reason I mention OS waiting tasks is if a particular thread is waiting for CXPACKET waits, or in other words, it has gone parallel and it's going to be split among different CPUs, we will show you in VM OS waiting tasks how many threads that particular task has been spawned out to. So in sys.vm OS wait stats, and OS wait stats is going to be the main DMV inside SQL Server that you're going to use to identify the resources or the wait types that we're waiting on, how long we're waiting on it, and the amount of times that we're waiting on it. That's going to be your go-to DMV. Resource wait time, which is the wait itself and how long we're waiting on that particular resource, plus the signal wait time, or the amount of time that that thread is spending in the runnable queue, represents the total wait time. That's the overall wait, or how much time we're waiting on a given resource. So in terms of mapping waits to queues, we have different wait types, such as page I/O latch. And I'm going to talk more about these wait types in a few minutes. Async I/O completion and write log. These are three different types of waits associated with three different types of resources on the system. In terms of queues or perfmon counters, for page I/O latch, we may want to go look at the disk queue length, which is consistently high. Disk queue length, you have to take a number of factors into consideration for disk queue length. But if you know the number of disks on your underlying disk subsystem and you know that your disk queue length is high, given those number of disks, that may be something to look at. Why is my disk queue length that high? Am I running some really expensive queries and they're just not returning quickly? Async I/O completion, is my disk seconds per read and my disk seconds per write also high? In other words, my disk latency. If I have a high write log, how big are my log flushes? And how often am I flushing out to my log file? If I have really small log flush sizes and I'm flushing out really frequently, does that mean my transactions are too small and I'm just inundating my transaction log, my underlying disk that my transaction log's on? So what are some possible conclusions? Is my I/O subsystem not able to keep up? Am I running really expensive queries under the covers that are scanning really large tables and I have to bring those pages from disk into memory, which would probably affect page life expectancy, maybe, depending upon how much memory I have on my system. High I/O bandwidth issues, maybe my application is really needy and my disk subsystem just can't keep up. Or maybe my application is really chatty, and because it is writing out so much to the transaction log, maybe I need to do some things to tune that application so that I'm not committing such small transactions. Okay, so just the idea here is that I know what I'm waiting on. I can go verify through perfmon what I'm waiting on, and hopefully that'll give me some insight as to why I'm waiting on it. And that will lead me to different conclusions based on what my perf counters are telling me and what SQL Server is telling me. So there's two different stories here. is what SQL Server is telling me and what the underlying or the overarching server is telling me. And if they match, then that leads me to different conclusions. So how do I read sysdm OS wait stats? You have the wait type, which is going to tell you the resource that we're waiting on. You have the number of times we have waited on that resource in the system, so how many times we're waiting. You have the total wait time, so you can get the average time that we're waiting on that given wait time. If I take the total wait time and I divide into it the waiting tasks count. My max wait time, what's the largest amount of time I've waited on a given resource. So I can see here that in milliseconds I've waited around 6.5 seconds as the max wait time for a given lock on my system. Signal wait time is how long in milliseconds on I am waiting for, and this is overall, and this is a summation, I've waited to get onto the scheduler. And so once I've received my lock request and a worker thread has told me, hey, you've got your resource, how long it's taken me from that point to get onto the scheduler. So how long we've waited in the runnable queue. A few notes on wait stats in general. Not all of these are going to be useful to report on. Typically, we're going to accumulate the amount of time we've waited for a resource after the resource has completed, and the granularity there depends on the type of resource that we're waiting on. So, for example, locks, we only will report how long we've waited on a lock after the lock has been granted. Okay, so something to keep in mind. It should be, in most cases, it should be fine, but if I'm waiting on a lock for several hours, it's probably not going to show up there, and so your reporting may be off if you're depending on that. Viewing as a whole may or may not be useful. So if I go and I look in sysdm OS wait stats and it doesn't show me anything of use, i.e. I've not been waiting on a particular resource for that long as a whole, that doesn't necessarily mean anything because sysdm OS wait stats is accumulated since SQL Server was last restarted or the last time I cleared that particular DMD. So I may have to take snapshots of that DMD every hour, every 4 hours, and then take a delta of those two captures to see what I'm waiting on. And it would be useful to do that throughout the day as well. And so you'll know that what you're waiting on throughout the day. And a lot of third-party tools out there, they do that. They'll do that for you. So on your system, if you're experiencing a high number of waits for either overall or for a certain period, they're going to be likely one of the following. And I'm going to try to explain to you what these different waits mean and how you can go and verify or look in Perfmon to see if you're experiencing these waits. So one of the main that I run into a lot is WRITELOG, and we accumulate a WRITELOG wait occurs whenever we flush a change to the transaction log. So we write log changes to log buffers, and eventually something happens and we have to write those changes out to the log file. So if I see a high amount of write log waits, I can go to my disk counters, and I always use logical disk rather than physical disk because it represents what you see at the drive letter or the mount point. Average disk seconds per write or average disk seconds per read. Sometimes we do have to read from the log file, but mostly average disk seconds per write is how long it takes the operating system to flush a particular write out to that particular file. Okay, so if you see a high latency for write time, that could be a problem for you. Average disk bytes per write, how big these IOs are that we're writing out to the log file, and that should match up somewhat to the size of the log flushes. Okay, so the database counter log flushes per second and log flush write time, how often I'm writing out to the transaction log for that database, and how long it's taking me to write those flushes out. Sysdm IO virtual file stats, we keep track at the file level stall information. So SQL Server, once we issue a request for an IO, until we get acknowledgement back that the IO has completed, we call that a stall. And sometimes it will match up to average disk seconds per read and average disk seconds per write. It doesn't always do that because if for whatever reason, we have high amount of CPU on a given server, and SQL Server worker threads are busy doing something else, then that stall information will be ballooned, and even though the write has been completed at the operating system level. Okay, so something to keep in mind there. SysDM IO pending IO requests. Whenever we issue an IO, that'll be a pending IO request, and as soon as it's completed, it should not show up in this DMD anymore. So if you are collecting from this DMD, and I would highly encourage you to do that, you can see how long these IO requests are taking, whether they're write IOs or read IOs. And essentially, if you run a query against this DMD and then run it again a couple of seconds later, if an IO is still pending, that's a problem and you need to investigate it. But I've solved a number of problems out there by capturing on a customer system IO pending IO requests so that I could chart over time to see what's causing these problems. And there's been a couple of issues that we've seen related to that, usually with high CPU. CX packet waits. This just means that you have parallel queries on your system. This is not a good thing or a bad thing. It's just something that happens. For OLTP workloads, it's usually less desirable, especially if you have some sort of reporting query out there that can go and contend with a lot of other schedulers to try to performance work. Okay, again, it's not a good thing. It's not a bad thing. You need to know what your system's trying to accomplish. If I have a data warehouse and I see a high amount of CX packet waits, that's not going to bother me one bit. But if I have an OLTP system where I'm expecting really small transactions that are happening really quick, and I see a high amount of CX packet waits, I want to try to figure out why. All right. So here, SysDM OS pending tasks and exec query stats are your friends. OS waiting tasks are going to show me the tasks that are running, that are parallel right now. And exec query stats are going to show me plans in cache that have a parallel execution plan, and I can run XML queries against these plans that are being returned from exec query stats. Exec query stats is one record return for each statement that's in the plan cache, and you should be able to go out and do a couple searches on the internet to find some XML queries to run against exec query stats to find the plans that are parallel. Again, it's not a good thing, it's not a bad thing, it's just something that you want to be on top of. Okay. Usually if I see a high amount of CX packet waits, I don't really ask anything unless it's taking up a huge percentage on the system, and then I start investigating, especially if it's an OLTP style workload. I'm not encouraging you to go and turn a max DOP of 1 on by any means. Just something to keep in mind because this is a pretty frequently seen wait type or high wait type out there. SOS scheduler yield. This is when a thread voluntarily takes itself off. You know, I mentioned a quantum concept earlier, and SQL Server threads or worker threads will take themselves off the CPU so other threads can perform their work as well. That's what a SOS scheduler yield is. It's not really a problem unless it's a very high percentage on the system, and typically when you see a lot of SOS scheduler yields, you'll also see a pretty high processor usage. Okay, so you can look at processor percent user time. You can look at context switches to see if your context switches are really high. We're talking in the many thousands per second. You can look at SysDM OS spinlock stats, and what spinlock stats is going to tell you is so spinlock is a very lightweight programming construct that we use to try to get access to different data structures. And so if we can't get access to a data structure, we'll wait a little bit, and we'll put ourselves into a tight loop, and we'll try to access it again. And so for different, you can think of them almost as wait types for different spinlock structures. And if you see a high amount of spinlocks for just a certain spinlock, we're talking probably in the high billion number range, and you have a high CPU percentage usage, then that's something to look into. Right. SysDM exec request, you'll see this as the wait type showing up for a given session, something that's running right now. It'll be a SOS scheduler yield, and then if you see a high percentage of those, or you see a lot of those when looking at exec requests, that's something to look into as well. Page IO latch, this is where we are bringing a page from the data file into the buffer pool. All right, so the more that we're bringing in, the more work we have to do. Look at average disk seconds per read, or the latency that it takes to get that page from disk into memory. Disk bytes per second, or what our throughput is for our disks, and compare that to what we're expecting. Checkpoint pages per second, how often we are writing dirty pages that are in the buffer pool out to the data file. Okay. Page life expectancy, this is how often, on average, we can expect a buffer to stay in the buffer pool without references. And the higher the number there, usually the better. Now, I may end up getting questions on should I be looking for that 300 second page life expectancy, and the answer is no, just because most servers these days have a lot more memory than whenever that recommendation came out. So it's more important to have a baseline and know what your page life expectancy should be as compared to just comparing it to some hard and fast number, because usually that doesn't make too much sense. IO virtual file stats, that's where I can get my stall percentages or my stall values and see if I'm waiting on a particular file for too long, which if I'm waiting on a file for too long in terms of read and write stalls, then I want to go back to average disk seconds per read to see, and average disk seconds per write to see if I'm having some sort of bottleneck on my disks that are supporting these transfers from disk to memory. And again, look at IO pending IO requests, capture pending IO requests, just to see over time, am I waiting on particular IOs for too long from certain files? Do I have a problem with a certain file and not necessarily a drive? Page latch, this is where we are waiting for a page that's not associated with an IO request. This is usually, when I have seen this problem in the past, this is associated with some sort of temp DB allocation problem. So we're waiting on a SGAM extent to be modified, or we're waiting on a PFS page in memory to be modified, and it's just not happening fast enough. So we're using temp DB way too much. Maybe we're using multi-statement table value functions where we have to go and allocate a table variable to be able to use it, and we're just allocating thousands and thousands of them. Or it could be a hot page in memory. So like using an identity column and just writing to it a whole lot. So you'll see these in exec requests. You'll see this in this sys.dm OS waiting tasks. And if I have a particular page number, which will show you in exec requests, I can look in sysdm OS buffer descriptors, or I can use ddcc page to go and find what type of page that is. So mostly you see a high percentage here. It's more than likely going to be temp DB, but it also could be some sort of hot page in memory associated with a really busy table. That's not temp DB. Async network I/O, this usually happens because you have an application that has requested a lot of information, whether requesting a lot of information over the wire from SQL Server. We only have a certain number of packets that we can use, and once we've used all of those packets, those TBS packets, to transfer information from SQL Server, we have to wait till more packets are freed up. So it could be a network issue. Usually it's not. Usually when you see a high amount of async network I/O, it's related to a application that has requested a lot of information and they're just not processing it fast enough. OLTP, this occurs when we're waiting on some sort of OLTP provider. A lot of times when I see this, it's associated with third-party tools that are calling a lot of DMVs to pull information from the database and do some sort of charting with it. It could be with link servers, it could be with RPC calls, or OpenROSET, or even Profiler, but usually it's some sort of third-party provider. Locks, this is where we're waiting on a lock. Right? So we requested a lock, and we're just waiting on it for whether it's a really long-running transaction or I just have a lot of activity and I have blocking on the system. So I want to go look out. I want to see, am I having a lot of lock escalation attempts per second? And that's an access methods perf_mon counter. I want to look to see how long on average I'm waiting on locks, which I have perf_mon counters for that as well. I want to see how much lock memory is being used. more lock memory is being used. Any type of lock that we're taking, we have to take memory behind the scenes, and that's why we will try to escalate a lock. So if we have lock escalation turned off and we're taking row locks for everything, then that could attribute to us having a high amount of lock weights. I can look at index operational stats at the index level to see what type of locks are being taken on those given indexes. I can look in SysDM tran logs to see the type of locks that are being taken right now. And I can look in exec requests to see the sessions that are currently waiting on some type of lock. Resource semaphore. This is a way where we have requested a memory grant and we're waiting on the memory to be allocated for our query. So this is not uncommon for data warehouse workloads. Resource governor can help here. The main thing to look at here is SysVM exec query memory grants, and I have several customers that will go and output the data returned from that VMD to a table so that they can chart it over time. And then there's memory grants pending. That's a counter that will return the amount of memory grants on the system that are waiting to be serviced at a time. So they've requested memory, but SQL Server hasn't given them memory yet. You want this, in most cases, this counter is going to be very close to 0. If it's over 0 for a prolonged amount of time, that's reason to look to see why I'm having outstanding memory grants. And it could be just really expensive data warehouse queries, and that's fine. But if it's on an OLTP style system, then that's something to look at as well. Something to research for sure. Looks like I have about 9 minutes.
Tim, you're at 8 minutes.
Yep.
Yes.
Okay. Thank you. So for some useful memory counters, if I'm looking at if I'm having memory problems, where do I want to go to focus? First thing I want to do, I want to look at SQL Server Buffer Manager. I want to look at my page life expectancy, and hopefully I know what my page life expectancy should be, and I can compare what the current value is. Not only that, is I want to be able to look at a large time span for my page life expectancy to see if I'm having any sort of sawtooth pattern, where I see my page life expectancy jump up and then it falls off a cliff. If I see that type of thing, then in most cases it's going to be some sort of really expensive query or queries out there that are flushing out my buffer pool. Checkpoint pages per second, how often is my checkpoint process kicking in and writing out dirty pages to my buffer pool? The number of free pages I have, the lazy writer is responsible for maintaining a certain number of free pages in the buffer pool, and if lazy writer starts kicking in and my free pages are low, which would be why the lazy writer would kick in, maybe I either don't have enough memory or I am having memory pressure and I need to figure out why. Always look at memory grants pending, and if it's over 0 for a certain amount of time, I investigate why that is. Okay, you may have some really expensive queries out there and it's not a data warehouse system that's causing you problems. Look at the working set for SQL Server. Now you have to take this with a grain of salt because depending on whether you're using locked pages in memory or not will have an influence as to in terms of how much memory shows up for SQL Server for the working set, because we have to use the AWE API behind the scenes. So you can also look at the private bytes for SQL Server to see what the amount of memory being used. In terms of the amount of memory that's available on the system, if I have a very low amount of available megabytes, then I may just need more memory on my server. Okay? But if I have a very high amount of megabytes, maybe I have 20 megabytes available megabytes or available gigs for my server, and it's usually at 20 gigs available, then I can look at if I have capped my SQL Server working set or my max server memory, then I can allocate from what I had set for the operating system to SQL Server, so max server memory can be increased. Useful CPU counters. If my CPU is being used in a sustained rate and it's very high for a long amount of time, then that's a sign of an underlying problem. So look at my batch requests per second. Look at my processes out there to see if there's any process that's eating up CPU that should be allocated for SQL Server eating up CPU, so you have to be very careful with the processes that you have installed on a SQL Server machine, if it's, assuming it's dedicated, because you could have a rogue process out there eating up CPU as well. Look at your amount of compiles and recompiles per second and compare them to the baseline. I should have time to get through these last few slides here. I want to make sure I get to them. Logical disk, I always look at logical disk counters in terms of I/O because it gives me information at the drive level. I look at average disk seconds per read and average disk seconds per write because that's going to tell me what my latency is for disk. Disk transfers per second, or my throughput to disk, reading to and writing from disk, and percent idle time, how idle my disks are. If my disks are being used close to 100% of the time, maybe they're just overworked and I need to add more disks to my underlying disk subsystem. So some other settings I want you to be aware of. Power settings on the server are very important. If you are at a balanced power plan, even though the Windows operating system says recommended, change it to high performance for SQL Server. Okay. There is actually a perfmon counter out there that I just learned about recently called processor information, and it's percentage processor performance. If you see, if you go and look at percentage processor performance and it's close to 100%, there's a good chance that you're going to be at the high performance power plan. But if it's in the 60s or the 70s, then there's a good chance you'll be at the balanced power plan, in which case you want to go to your control panel and investigate. So just another perfmon counter that you can add to your toolbox to check for a given server. Application level settings, always look at the processes counter. This is going to be one of the first things I look at. I go and look at I/O data bytes per second for processes and how much CPU different processes are eating up. For a given SQL Server installation that's dedicated, you should never have an application out there that's trying to compete with SQL Server for these types of resources. A lot of times we'll see antivirus that is contending with SQL Server or some sort of backup program that's trying to eat up a lot of I/O, which may or may not be a problem, but you want to look at your process counters to see if anything is competing with SQL Server. This will tell you if the application is installed as an NT process. It'll tell you if that application is requesting too much data or it's trying to use too much CPU. Filter drivers, always be cognizant of any sort of antivirus that's on a system. If you don't have the proper exclusions in place for not only the SQL Server log and data files, but also any of the SQL Server binaries, we've seen cases where this has disrupted a SQL Server processing, SQL Server performance. So be careful with these. And one thing to note is if you are having problems with a filter driver, in most cases it's not sufficient to just disable the filter driver or the program. In most cases you have to totally uninstall the program to make sure it's not affecting anything else on the system. So something to keep in mind there. So my last slide, which tool to use, and I had this in here from my 24 hours of past talk just as a good place to go to figure out when to use what. I didn't talk about the performance and or performance analysis of logs tool today. It's freely available from CodePlex 2. It's a great way to go and benchmark your system and to get familiar with your workload and to see if there's any underlying problems. You can get the tool from CodePlex, and it works best whenever you collect information from SQL Server using PSS-diag, and then you can load that information into PAL. It is a little bit slow. Okay, it's going to take a while for a large capture, but it does do a really nice job of explaining the counters and if there are any counters for a given SQL Server workload out of SKU. SQL PSS-diag and SQL Nexus, this is more targeted. This is going to allow you to go and not have to run anything manually on a system. You can put this on a customer server or have your customers run it, collect that information and have them send it to you, or you can do it on a system on your network and have a collection machine that you go and you run your reports against. So it collects pretty much any information that you want to collect, and it does a really nice job of giving you options for running reports against it and having your own health check. So that's all I have for today. If there are any questions, I will try to get to them if they are emailed to me. I'm sorry, I ran right up to the amount of time that we have, but I'll do my best to answer any questions that you may have. And I'll make sure this slide deck is available. I'll add a little bit of supporting information to some of the slides that are already in here, and I'll make sure that it's available for you to download.
So Tim, we do have a few questions, and I can run those through for you.
Sure. Yeah, I have time. I should know what the rules are usually for this type of thing. So
yeah, we don't have very many, so I think we can get through a few of these.
Yeah, sure.
So real quickly, the dialog manager, and I think this is on the PSS diag, is only showing SQL Server 2008 tab, and you had already talked about this, but just for reiteration, he asked about SQL 2012 and 2014 support.
Yeah, so that tab will only, so what it does is that tab basically sets in a configuration file the instance number, so 10.5, 11, 12, whatever the major version is of SQL that it's allowed to run on. But there's nothing stopping you from using the 2008, creating the XML file, which is just a configuration, and then going and modifying it. And in my 24 hours of past talk, which I have a link to in this given presentation, I show you how to do that. Okay. It's actually pretty simple to do, but unfortunately for our public version, we just don't have it so that it does it for you right now.
Right.
But
okay, great. Is there any standard values for CPU time unit values?
Are there any standard values for CPU time in terms of unit values? I mean, it's a percentage, so usually I look at overall or look at it based on each individual CPU. So it's a percentage usually from 0 to 100, right? So if you look at the total, and the total is much greater than 100, you just want to look at each individual CPU.
Great. Are there any tools to analyze perf data easily and quickly?
Yep, I mentioned, well, easily yes, quickly not necessarily. I mentioned it at the end. It's the performance analysis of logs tool, which I have up on the screen right now, and it's a link to the download. And so what that'll do is it will take a BLG file, which is your perfmon information, and you'll load it into this PAL tool. And there are actually different templates that you can use. One of them is for SQL Server, and so you can go out, select the SQL Server template, and it'll have a bunch of rules for SQL Server related information, and it'll go and run its rules. It'll create a nice report for you so that you can see if there are any problems on the server. The only downside is that it's kind of slow sometimes, so you have to take that with a grain of salt. But it does do a really nice job of doing the analysis, and it does create some really nice charts for you.
Great. When a session hits the quantum limit of 4 milliseconds, does it remove itself to runnable or to waiting?
It will remove itself to runnable. So it just goes back to the end of the runnable queue. It's not waiting on, assuming it's not waiting on some other resource, it'll just go back to the end of the runnable queue to wait to get back on the CPU.
Great. And we have an attendee that says he really liked your comment about verifying what SQL Server is telling you versus what Windows is telling you. And he just wants to understand, so compare perfmon data against weights. You'd have to compare perfmon data against weight stats, and can you give a few examples how would it match?
Yep, I have a real good example. So in this case that I ran into, if you look at D&B information, D&B information is showing you, and I'm talking about IO virtual file stats. In IO virtual file stats, there is a column in there. There's a couple of columns, and there's for stall latency. And what stall latency tells you is whenever SQL Server requests an IO, whether it's a read IO or a write IO, and the time it gets the acknowledgement back. Okay, so that's not at the OS layer. That's at the SQL layer. Okay, and so I want to say that shows up also as a page IO latch. It should, but I would have to verify. But in this particular case, I would see a very high value for the stall information. But looking at the disks, I didn't see hardly any disk latency for reads or writes against the particular files that were the culprits, which didn't make sense. But as a side effect to that, the reason the stall information was so bloated was because the CPU was overworked, and the threads that were waiting to get satisfied for their IOs, because the operating system had already returned the IO back to SQL Server, but the threads were waiting to get that acknowledgement that SQL Server had received the IO, so the stall value was really high. So SQL Server would tell me, hey, you have a disk problem because I'm not getting that IO back quickly enough, but the Windows subsystem is servicing the request in a proper amount of time. It's just SQL Server was bound by CPU and wasn't able to get to them quick enough. So that's one example.
Great. Let's see here. Can you please let me know whether the logical disk partition is good or bad for SQL Server performance?
Can I let you know if a logical disk partition is bad or good for SQL Server performance? I guess it depends on the underlying disk subsystem if they can keep up with what SQL Server is requesting. Right? So I don't, if I understand the question right, it's not necessarily a good thing or a bad thing. It all depends upon the disk in how, if the operating system is really involved in that logical partition. So that's the best I can answer that one.
Okay.
Yeah.
Any suggestion for or guidance for performance troubleshooting multidimensional and tabular?
That's not part of my skill set, so I don't know a whole lot about that, the SSIS engine. So I would say that a lot of what we talked about today applies, especially in terms of perfmon, but in terms of actually troubleshooting SSIS, I've not done it before, so I can't relate to that too much.
Okay. Let's see here. When we talk about wait events, it is correct to calculate total wait time milliseconds per wait task to know the average time is spending each query that has this event. Why PLE sometimes suddenly jump down and there is no increase of lazy writer, full scans, or requests per second?
Okay, so I think I understand that question. So you could have your page life expectancy go in a sawtooth pattern because the checkpoint process will go out and remove those pages and make sure that those pages are written to the data file, so those pages aren't dirty anymore, so we don't need them in the buffer pool. What Lazy Writer does is Lazy Writer will find the pages that are dirty in memory and then write them out because we don't have enough free pages in memory. And so it's only going to register if we've actually written something out. So that's Lazy Writer. That's to write something out. So in that case, you'll probably see checkpoint kick in and start removing those pages, or at least making sure that they're no longer dirty. If you don't have a high number of dirty pages, then neither one of those will look like they're doing anything.
Fantastic. Let's go for just one more,
Okay.
and then any residual questions I think can be sent to you if can be reached out. So let's see. I normally collect batch requests per second and transactions per second, but have always wondered what's the difference between transactions per second and write transactions per second. Do you know the difference between these two?
I think the question is, basically they want to know the difference between the batch requests per second and transactions per second. Batch requests, I could send one round trip to SQL Server, and that's a batch. Okay. In that batch, I could have multiple statements, and each one of those statements is an individual transaction. They could be one-to-one, but they could be so that you have a lot higher transactions than batch requests, just because a batch can have multiple transactions.
Okay. Sounds good. Anything else that we need to wrap up with?
I think that's about it. Just because of time constraints, there were a couple of slides that I wasn't able to get through, and I kind of skipped over them. So I would encourage people that did enjoy it to go and download it from wherever you guys put it, and I'll send it to you after this, so that you can you can cover the slides that I didn't have time to look at.
Okay. Sounds great. Tim, thank you so much for your time today, and thank you everybody for joining us.
Yeah, thanks everyone.
And we will, again, we'll have this posted to the website in about a week with the slide deck.
Awesome.